to introduce our next plenary speaker, Dr. Hansen Person from Malaysian Agriculture Research and Development Institute. Okay, so Dr. Ganison is a Deputy Director for Fertilizer Technology Program for MARDI. He started his career as research officer in MARDI on 2000. Obtained a bachelor degree in microbiology and master's in mushroom biology from Institute of Malaysia. And he got his PhD in plant growth promoting rhizobacteria from University of Sydney. His areas of interest are biofertilizer, mushroom science, agro-waste management, and induced systemic resistance. Spent almost 15 years in bio-prospection and manipulation of plant growth promoting rhizobacteria for microbial inoculant development as biofertilizer or ISR, inducing inoculants such as bio-nature, dieback buster, and Gladiator 1.0. Okay. The dieback buster was commercialized and the Gladiator 1.0 in the pre-commercialization process. Lead many research projects in the field of PGPR, agro-waste management, and mushroom production technology. So he received 25 innovation awards since 2005 from various local and international innovation competitions. Currently, he's an executive member of Malaysian Plant Growth Promoting Rhizobacteria Chapter of Asian PGPR Society and local organizing member for the 7th Asian PGPR International Conference to be held in 2021 in Malaysia. Okay, without further ado, I pass the floor to Dr. Ganson.
Excuse me, I thought I'd submitted pre-recorded presentation.
Yes, Dr. Ganison, I will pay it now.
Yes,
right.
Thank you. Hi, good morning, everybody. First, I would like to thank the organizer for giving me an opportunity to present in this Banana Congress. The title of my presentation is An Induced Systemic Resistance Approach to Better Bananas. Today, I would like to sharing with all of you about my experience, how we had equipped the banana plants with the weapons and shield to protect itself from the infection of the blood disease by using induced systemic resistance approach. Banana is an important cultivated fruit in Malaysia, which was cultivated in 30,684 hectares, generated 45,850 tons of banana in 2019. The important varieties are Berangan, Cavendish, Nipa, Awa, Abu, Masa Hijau, and many more. Banana considered as Malaysian favorite fruits for fresh consumption and cooking. The consumption per capita in 2015 was 9.3 kilogram and increased to 10 kilogram in 2017. And we also exporting banana mainly for Singapore, Brunei, Hong Kong, and Middle East. In 2007, we encountered a new challenge with the banana production in Malaysia, the emergence of a new disease, banana blood disease, which was caused by Rolstania syngzii subspecies celibacensis, which started in Johor and spread to the whole country. In 2014, 61% of the cultivated area in Johor was infected, and all the important local varieties, the commercial varieties, are susceptible for this disease. Today, there is no any efficient control against the disease, and the damage can go up to 80%. And this is the symptom of the disease on the fruit stem, the trunk of the bunch, the fruits, and the plants will be affected with the disease, the farm affected with the disease. And this is the causal agent, the Rolstania syngzii celibacensis. The impact of a banana disease is quite big for the Malaysian banana industry. Farmers refuse to cultivate mainly some susceptible variety because once the fruits are infected by the disease, the fruit cannot be sold. So they don't want to lose. So they don't want to cultivate certain varieties. Production reduced significantly. Insufficient supply for domestic market. Therefore, we importing in banana. In 2007, when the disease started, our import of banana was just 0.09 million. But in 2019, the value went up to 28.3 millions or under 20,000 Malaysian ringgit. Mainly the banana imported from Philippines and other Asian countries like Indonesia and Philippines, Indonesia and Thailand. There are various techniques has been tested to control the disease, chemical control using pesticides and biological control, systemic acquired resistance and molecular approach, but none of them succeeded in control of this disease. There is no resistant variety with excellent eating quality to replace the existing susceptible commercial varieties. One technique less explored was the induction of the systemic resistance in the plants against the disease, which is known as the induced systemic resistance. ISR is defined as an enhancement of the plant's defensive capacity against a broad spectrum of a pathogen and pests that is acquired after appropriate stimulation, which can be triggered by plant growth promoting rhizobacteria. PGPR is defined as a heterogeneous group of non-pathogenic free-living bacteria that is associated with the plant roots and mediate improvement in plant growth and or health. Generally, plant growth promotion PGPR has three main traits. One is a biofertilizer, bioremediation, and plant health enhancement. For plant health enhancement, the common mechanism involved is biological control or induced systemic resistance. Generally, any of the PGPR may have more than one of the traits I mentioned just now, or they may have all the three traits. So the objective of MARDI is to develop an ISR technology to control the blood disease of banana, so the disease can be managed efficiently. To achieve this goal, we had conducted three activities. First, isolation of a PGPR for ISR induction against banana blood disease, screening of the isolated bacteria to select the strain which have ISR induction trait, and testing of that of ISR seedlings by the bacteria which developed by using the bacteria from the step 2 and tested on the hotspot in the open field. For the first step, isolation of Bacillus, we collected soils from the banana cultivated area from 3 different varieties: Berangan, Rastari, Crossembone, and one unknown variety. And the Bacillus was isolated by using 2 different media, MEYP and Pemba. In total, from these 3 varieties and using these 2 media, we managed to get 54 Bacillus, which may have may potential to as ISR activity. First, we bought a banana plantlet. We prepared the individual 54 bacterial suspension individually. So each treatment, we put one individual bacteria suspension. We dip the root of the plantlet in the bacteria for 1 to 2 hours. Then transfer it into a germination tray containing peat moss and leave it for 2 weeks until it stand up very well. Then transfer it in a poly bag containing 3 to 1 soil mixture. 2 weeks and after the seedling transfer in the poly bags, we apply a booster application of ISR inoculant in the rate of in the dilution rate of 50 ml each time application, and we leave it to plant for 2 months. Then after that, we challenge with pathogen. For pathogen challenging, we took the second leaf after the youngest leaf. We took the next leaf. We injected 5 ml of Rolstania's syngzii, the bacterial suspension. Then we leave it for 2 months. 2 months we maintain with all the watering. We make sure there's enough water. It's not wilted because there's no enough water. After 2 months, we found that all the controlled had succumbed to the blood disease, totally wilted and died off. But you can see that this is one of our ISR treatment, the positive ISR treatment, IB43. You can see all the plant is a healthy, green, and still survive. Out of 54 ISR, 54 bacteria, 54 isolate bacteria we used. I only shown the data for 23 years. From that, another 31 is already totally all of them succumbed to the blood disease with the 100% of disease severity. Here you can see the disease severity from 0 to 100%. At least 17 of them shown a certain level of resistance against the disease. The lowest with a 10% resistance, but we also have at least 3 bacteria, BIP10, IB43, and IB58, with 100% resistance against the disease, and another 2 isolate with 25%. These 5 isolate was selected for our future works to be testing in the on the hotspot open field study. For field evaluation, we had prepared banana seedlings in our glass house. We transferred it and tested it in our Mardi Sinto in Kedah. By the quality of the seedlings were evaluated. You can see the seedlings height. After 2.5 months, at least 3 of them have shown better height than the control. The best one is a BIP35. Then for the pseudo stem girth, almost all the ISR treatments shown better stem size. From this quality evaluation for the seedlings, we found BIB35 was the best treatment, which recorded the best producing the best or vigorous, the best vigorous seedlings to be used for on the field. You can see this is the photo after 2.5 months. The left is the non-ISR, the normal control, and this one BIB35 after 2.5 months. Both were sown on the same day. We had selected a plot in Mardi Sinto. This was the germplasm, which was infected by the blood disease. This was a symptom of the plant, which we cut off. You can see the symptom. The plot we selected was just 20 meters next to the germplasm plot. It's a very poor soil, sandy loam soil, Nangka series, less fertile. Previously, we tried to develop establish a germplasm here, but it's a fail because of the low fertility. So we selected this plot because of the disease and the low fertility. The seedlings transferred to Mardi Sinto were kept in the nursery for 2 weeks, and we wanted the plants to acclimatize to the wet weather of the Mardi Sinto. After 2 weeks, we transferred to the field. Then every month we apply with the ISR inoculant and the chemical fertilizer as a recommended rate. The inoculant application was 5 milliliter per plant, which was diluted with 1 to 70 dilution. So each time we apply 350 milliliter of 350 milliliter of ISR inoculant, diluted ISR inoculant, which we drench in the root region. This was the plot condition after 5 months. The plants look very, very healthy, green. Then we took some plant growth parameters, the height. You can see generally all the ISR treatment shown a better growth, taller than the control. Then the best treatment here was IB43, and after that followed by the BIP10. You can see the photo taken on the same day. This one after 7 months. This was the control. You can see the level of the head of the our workers and the crown of the plant. You can see here, much taller. And at the same time, you can see there's some start for producing fruits in before 7 months. This was a treatment IB43, which start producing flower as early as 6.5 months. Generally, for Berangan variety, we need up to 8.5 to 9 months to produce the flowers. So the ISR treatment had induced early biological maturity. Then it's produced a flower. Of course, when the flower produced earlier, the yield also can be harvested earlier. Then we took the leaf length. Again, all the ISR treatment given a bigger leaves, which indicating there's a more surface area with the chlorophyll, more photosynthesis can happen, and more starch can be deposited in the fruits. You can see in the yield later how it is the leaf size will influencing the yield. This was a photo taken on the 9 months. You can see most of them to be harvested in a 9.5 or 10 months. But this time only the control start flowering. So this one showing the ISR treatment is giving a better growth for the banana plants. For the length of the bunch, you can clearly see that all the treatment given a bigger bunch than the control. The control recorded 0.9 meter length, but the best treatment, BIP35, recorded 1.31 meter length, followed by IB58 and IB43. If you see the yield, you clearly can see that the control is the most inferior with a 7.3 kilogram per bunch. The best treatment was IB35, 14 kilogram per bunch, followed by the IB43, about 13.6 kilogram. Others are in the range of 11.9 to 12.3 weight per bunch. If you see the number of combs, that is not much different, although there's all the treatment shown higher comb numbers, but it's not really that significant to show that it's really influenced the yield. Just now where the control was almost 7 kilo compared with IB 35, 14 kilo. And IB 35 producing 92% extra yield than the control, but you cannot see that one, that pattern here in the number of comb. But you can see here clearly, each comb produced by the treatments are heavier than the control. The control produced average comb weight for control was 1.1 kilogram, compared with the IB35 and IB43, BIP35 and IB43 recorded 1.9 kilogram per comb, giving extra 800 gram per comb. And other treatment recorded about 1.4 to 1.5 kilogram per bunch. You can see the fruits here. This is the BIP35, very compacted, bigger size fingers, banana fingers. Compared with this, the control, you can see the distance between one comb to another. There's a space. So that's the reason why we can say this ISR technology is more productive in producing banana. In terms of disease infection, once we are cultivated in the first 3 months when there's a rainy season, you can see the disease infection. The control recorded 24%, and only 2 treatments, IB43 and BIP23, recorded 8% of infection. This was the photo taken during the first season, the plants infected by the blood disease. But when it's other 3 treatments, totally there's no disease recorded on the first ratoon. But when we go to the second ratoon, you can see that there's the disease severity increase. The control went up to 36%. 2 treatments, 43 and 58, recorded 16%. Another one, BIP23, had recorded 6%. And BIP35, only 4%. But the best treatments here was a BIP10, which until the end of the second ratoon, there's no any disease infection was observed. To have an efficient ISR technology with maximum control against the disease and the best yield, we must have 2 components together. First, we must have a ISR inoculant, which we can use to produce the ISR seedlings. Once you apply this technology in the farm, you must cultivate ISR seedlings, followed by the continuous routine application of Gladiator 1.0 of ISR inoculant on the field until the termination of the production. If we use any other non-ISR seedlings we apply with the Gladiator, the effects of the disease control or the productivity will be varied from what I have presented here. It was concluded that the 54 potential ISR inducing bacillus were isolated and 5 were identified, which among them 3 recorded 100% control and 2 with 75% control. And we use it for test in the open field. ISR treatment shown better vegetative growth, early flowering and fruit maturity. All treatment generated more yield than the control. For blood disease resistance, against all the treatment recorded lower disease incidence compared to the control. For the first return, control recorded 24%, two treatment 8%. For the second return, the severity had increased. The best treatment selected for future works was BIP35, BIP10, and BIP35, which recorded 0 and 4% casualty after 2 returns. We also want to explore other potential of ISR technology. Is it just only good to control blood disease or something else? For that, we can see there's a emergence of another bigger threat for the banana industry, Fusarium wilt, which was caused by Fusarium FOCTR4. Even FAO said banana Fusarium wilt tropical race 4, a mounting threat for global banana markets. Main banana producing country in the panic mode because there's the threat given by this disease, and they also maybe we also have a problem with the lower or less banana will be produced, then maybe the price will go up. Especially it's going to be a big issue in the country which using banana as their staple food. So we are looking the possibility. Is it possible to manage blood disease and Fusarium wilt with the same ISR technology? Is it possible to kill 2 birds with one stone? To answer these questions, we have to do more research. Therefore, we started one experiment to explore the potential of ISR technology in control Fusarium wilt in organic production. So by using this experiment, we can see whether the ISR technology is suitable for organic production and at the same time can control the Fusarium wilt. This was a plot we selected. We felled the plant and cultivated. This was a multi-integrated organic farm, and this was a hotspot. The previous plant, this was the previous plant, and we chopped down, we felled and cultivated ISR banana. And within 2 kilometers of this plot, we have one plot which was infected by the blood disease as well. This plot, this organic farm previously was a banana, a muddy banana germplasm. There's a lot of FOC even from a long time ago. ISR seedlings were prepared and tested for organic production. Organic fertilizer and ISR inoculant was applied once a month. ISR applied like what we did, a drenching on the soil with a 170 dilution and 5 milliliter per plant. Vegetative growth performance were evaluated. Spread data was taken. Yield data will be collected when the bunch mature, and disease incidents were collected. This is how we are planting the plants. We applied organic fertilizer, application of ISR inoculant, and this is how our people is taking data. This was the most recent photo about 3 days ago. We took the plant height, the basic plant growth parameters. You see, generally all the treatments were much better than the control. Here, the best treatment was IB58, followed by the BIP35 and BIP10. Then we go for the stem girths. Here, all the treatments also given better, bigger girth than the control. Here the best treatment was IB35 followed by IB58 and also BIP10 on the third rank. But when we come to the spat reading, you can see for the first two reading on 30 DAT and 200 DAT, there's no difference in the control. But in the treatment, you can see generally all the treatment either reduce or remain, at least reduce a little bit for BB 2023 is reduced a little bit. But generally all the treatments shown a higher spat reading compared to the control for the both recording. And this indicating there's a more chlorophyll, more photosynthesis can happen, and we are expecting the plant is more vigorous and more yield can be generated, and the plant is possible to attain its biological maturity earlier and produce the fruit, produce a flower earlier than the control. This was the current status of ISR organic plot. Generally, all the ISR treatments produce taller plants than the control. ISR treatment generated bigger stem than the control. ISR treatment recorded ISR reading. As I told you just now, treatment IB43 recorded early flowering pattern 6.5 months after the treatment, and control and other control and other treatments and control have not flowered yet. This was about 5 days ago. You can see the photo here. And as I told you, this is the same pattern as what we've seen in Madi Sinto. IB43, after 6.5 months, it starts for produce flowering. Another 80 days, 80 to 85 days, we can harvest the fruits. There's no blood disease of Fusarium wilt was observed yet. Maybe this is the first return. But Syngzii disease was common for control and all the treatments in this plot, and also the same as a Sinto. But we managed to control it just by removing the leaf, and we spray some botanical pesticide. Then we want to testing again this this ISR technology to control the Fusarium wilt, FOC TR4, in another plot for inorganic production. This one in Jerangau. Previously, this is the plot which we felled the plants and we cultivated here. This plot previously, one of my colleague at the cultivated banana by buying the suckers from Perak. Within 6 months, all the plant was succumbed to the Fusarium infection because the seedlings was contaminated with the Fusarium pathogen, and 100% of the field was infected. But this is the next generation of the plants. And we had produced seedlings for him, ISR seedlings, but he put it next to this plot about 50 meters away. Until 3 seasons, all of them are ISR seedlings, but there's no disease. But we want to test in this one. This one considered as a hotspot, so we're testing here. Again, ISR seedlings were prepared and tested on this one for the conventional production system. Fertilizer and ISR inoculum was applied once a month. Vegetative growth performance was evaluated. Spray data was taken. Yield data will be collected, and disease incident were recorded. Now the plant's only 90 days old. Then we took the plant height. Here we can see the only BIP10 is better than the control. Other 3 treatments, 43, 58, and 23 inferior than the control. I think BIP 35 about the same. But this is still an early stage. We cannot see much the pattern. We must wait another 60 days. We can see that the treatment is going to be better than the control. When you take the girls, at least 3 treatments, 43, 58, and 10, better than the control, and also BIP 35. There's one treatment still inferior than the control. As I said, still this early stage. But when you take the spat reading, you can see the same pattern where this time the second reading shown a lower spat reading than the first reading, and generally all the treatments better than the control for the both data recorded in terms of spat reading. And this is the The best treatment that recorded tallest plant was IB83, but other treatment except BIP35 were inferior than the control. Generally, all the ISR treatment except B23 recorded bigger stem than the control. All the ISR treatment recorded ISPAT value than the control. No fusarium wilt or blood disease incident was observed yet, but maybe the disease will come in the later part. And they are Sigatoga infection. There's a common in all the 3 plots we tested, Sigatoga. So it is indicating the technology we developed is not, it cannot control Sigatoga very much, but Sigatoga is not a very big problem. We just can spray some fungicide, we can control it. Okay, we are looking for ISR technology for better banana. How it is going to contribute? When people want to cultivate banana, they're always looking for or buy high quality banana seedlings. The wish list for high quality, the feature for the high quality, they said must be vigorous, high yielding, disease resistant, producing high quality fruits. But unfortunately, when you buy, you won't get all these features. But with this ISR technology, we can induce a resistance. We can produce a more vigorous plants in terms of seedling stage and also on the open field. Early flowering can save up to 2.5 to 3 months. So when there is early flowering, we can go for early fruiting. Higher yield can give up to 92% in our Sinto experience, and they are more resistant against the disease. In our technology development, we never use any resistant variety. We just took a susceptible variety, make it more resistant by inducing the resistance by using a PGPR. Then you can see the banana seedlings here. This is what we produce in Mardis. It looks very green. And this is a barangan bunch we produce in Mardi as well. And this one we just we have some we bought some Nipa variety plantlet, but this was the remaining. We produced some seedlings. We just cultivated it not for research, but it's recently produced one bunch is up to 44 kilogram, and this was the ripened fruits. But they also can produce a better quality, even a cooking variety if we're using this technology. Then ISR plant contain more chlorophyll and content. This makes sense why you can get a bigger bunch, bigger fruits. Continuous application of ISR inoculant will improve the soil with a higher population of beneficial microorganisms and reduces the risk of soil-borne pathogen infection. So when you put a next crop, the risk of to be infected by the pathogen is a bit lower. The way forward, development of ISR technology which can suppress more than one disease with multi-strain ISR inoculant. That's we are looking for it. We want to use our existing technology to control the fusarium disease as well. We can see from the experiment we conducted in Mardi, Serdang, and also Jerangau. Evaluation of ISR technology and disease control on other banana varieties. We start working on a variety Tando. It's a cooking varieties. We just started. Maybe by the end of year, we get some data on the seedling stage. Evaluate the possibility for the reduction of insect pest infestation. They was say that this disease also can be carried by the pathogen by carried by the insect, and that was one of the reasons why the plant can be infected. We want to see this one. Then post our study to determine possible extension of banana shelf life. From our experience, whoever eaten our banana, the ISR banana, they found even after 5-6 days, the fruits, the flesh is still firm, and we want to see what happened, and if it is possible, you want to extend the shelf life. Currently, we are conducting upscaling of ISR technology in a selected commercial farm in Negeri Sembilan. We are going to start up another upscaling farm in Mardi Jelebu. And pre-commercialization by introducing ISR technology and ISR inoculant for many commercial farms. This we are going to start on the 2022. By the fourth quarter of 2022, we are expecting to produce 1,500 seedlings per month, and we will supply to the farmers in the various states in Peninsular Malaysia, and we will supply with the inoculant as well. By doing this experiment in different states, then we can conduct this insect pest infestation study, post-hours studies in that farm. Then we can have a better picture about this industry. More research on the ISR technology need to be conducted, especially for the efficient control of FOC TR4. Currently, we are searching for fund. If you manage to get a fund, you will develop an ISR technology for FOC to control the FOC TR4. Then we will try to combine this technology with the existing ISR technology for the blood disease. So we can control two diseases with one formulation, killing two birds with one stone. So you can see I was surrounded by my ISR seedlings. It is possible to produce a big scale if we have a proper planning. And the success of this ISR technology, it was mainly contributed by dedication and cooperation of my team member, which I listed here. Without them, within these 6 years, we are nowhere, and I also cannot present here. And finally, I would like to thanks for your attention.
Okay, thank you, Dr. Garrison, for the interesting insights on the ISR and its potential in banana. I'm afraid we are behind the schedule. Okay. However, should anybody have any question to ask Dr. Garrison, you may write down on the question in the chat box, and the organizer will convey the question to Dr. Garrison soon. Okay, so due to the time constraint, we have to move to the next session. So I'd like to thank Dr. Garrison for your presentation. So